All right, hello and good morning. Today I will be demonstrating my operating system security project. Now, the goal of my project is from a Windows framework. Like, it's a compilation of scripts that I wrote meant for case studies next semester. So, in my scripts, it installs our toolkit. It has a ton of weakening, so once we get onto a system, it weakens it so we can accomplish tasks a little bit easier, such as using more exploits in the future to get in, such as enabling SMB1, enabling plain text caching. So if I use Mimikatz, it'll give me all their passwords in plain text, and so it won't be hashed. And then the second part of this is persistence that we're going to go over. And then part three, which I'll add after, we were going to automate everything we do. So without further ado, let's get started. So I put my script on here already. It is also on GitHub on my red team repo that I made. So in the script, we're just installing a couple tools. We're installing evil WinRM, so it's like WinRM on Kali Linux, so I can actually just WinRM into a Windows box and run all those same like CMD PowerShell commands I'd normally be able to. Install Covenant C2, which is my favorite C2 framework of choice, absolutely by far. It is written in a .NET actually by Microsoft. And it actually works on Kali Linux too. So I had to do some finicky things to get it to work, just by installing .NET on here. So it's like the equivalent of installing PowerShell on your Kali Linux VM. And then also I have installed PowerShell Empire, which is my second favorite C2 framework. And that's just in case my signatures from Covenant or whatever get blocked. I have a backup C2, so I can kind of fluctuate between my command and control servers to interact with my victim target boxes. Then I have installed Unicorn. Unicorn is made for creating undetectable payloads, and it's really awesome. I have Shelter, which is also used for making payloads. And the cool thing is, it actually embeds your payload into another process. So, like, let's say if a user opens up putty.exe, it'll also spawn a shell as a sub process of putty. The next one is MPS payload, which is just another payload generator. And then here I have a payload signer, so it'll actually say my executable's been signed by Microsoft. This allows me to hide in plain sight. And this tool is called Limelighter. It's really awesome. A bit newer, and it's written in Go. The next one I have is process ghosting, so you can actually hide processes on the user like task manager. An advanced down header will still be able to see everything now, like they go through the logs and whatnot, and that's process ghost. Um, and I have PowerSploit, which is a persistence framework on here. It's not exactly C2, but it helps also generating payloads and just weakening a box and automating it. And then the last one here is just another undetectable payload generator. So without further ado, let me show you my tool working here. So I'm just going to run it. It's going to start installing everything. I'm going to speed up this because it takes a while, so you just don't get bored with me installing packages for my script. So let's begin the weakening process. So now for weakening, what we're going to do is create a weak SMB share that allows anybody to connect to it with full permissions. And if you want to connect to it, you just run this command here. We're also going to change the service permissions. So services like RDP, WinRM, and the firewall, so users can't like change the service status. They can't they can't disable the service, start or stop. This way, the services we own them. We can make sure like if we want to run Print Nightmare, the print spooler service will always be running, and they can't stop or disable it. On the contrary, we might have an op where we need WinRM, so we'll prevent them from being able to disable WinRM and prevent them from stopping it as well. I also have the SSH service, which we'll go into a little bit in a bit, but what we're going to do is, in the later part of the video, is install SSH on here, automate the installation of it and setup, and then prevent them from being able to disable the service or stop it, so we just have a free path to the system, keys of the kingdom. And then we're going to deploy some bad group policy objects. So I have my script right here to create the weak SMB share. As you can see, these are the only shares in here, the default ones with Active Directory. So now we're going to create the weak SMB share. Okay, now let's log into the weak SMB share from Kali. So I'm just going to open up my Kali box here, and if we just run this command here, that's my IP of the Windows box. We're going to log in as the guest. Doesn't have a password, didn't sign up for the guest. Bam, we are in the system. And we can interact with it however we want. This is only an SMB share, so we can't actually execute anything, but we can transfer files, which is still really good if we want to move payloads over and execute them later. Okay, now let's look at our other weakening mechanisms. So now we're going to change service permissions on various services. So for instance, like if you go here to Windows, just go to services.msc. Services. There we go. You can see we'll have like a lot of services here, and we're going to change these. So let's start with, here we go. So you see Active Directory Web Services. We have the ability to start, stop. We can enable, disable it, change startup type. Well, let's say we have a service that we don't want them to be able to stop or start. I have a script that does that, and this was actually probably one of the hardest scripts I wrote, but one of the absolute coolest. So let me copy it over from GitHub real quick, and we'll just save it in a file here. So to do it, I had to strip through the raw binary permissions of the service. And so this is like Windows version of like read, write, execute, but it's absolutely disgusting for services only. So let me just save it as service terms.bat. Okay. And now let's launch it. Success. So now if I refresh this here, let's go to one of the example services I have here. So let's go to DNS. Here it is, DNS server. So let's say we stopped it, right? Which during an operation would just be like net stop DNS. Well, bam, they don't have the ability to stop it anymore. I mean, start it. See, it completely changes this. So this really hurts teams too. I can also go further and change the startup type to lock this. I plan on implementing that in the future as well. The other ones I did were preventing starting up DNS. Let's go to print spooler. So I can run print nightmare. They can't stop the service. It's always going to be in a running state. I also did this for the Active Directory Web Services. So let's go up here. So let's say stop. Bam. This will take down basically AD. Well, it would also have to be in conjunction with this. It would take down a lot of stuff. I can also do it for the regular Active Directory services too, but they might be a little destructive on teams because that would destroy their entire domain. Also the firewall. Down here, Windows firewall. So let's say I stopped it too, like during an op again, like reverse shell, just say like net stop, the firewall service name, SVC, yeah, or MP, SSVC. So as you can see here, it's stopped, they can't turn it back on. And then also WinRM here. Windows Remote Management. Yeah, here. They also can't stop it, so we can just keep WinRM underneath the system, and there won't be anything they can do about it unless they shut the VM down, or if they can figure out how to do what I did with stripping the raw binaries. Great. Okay, so let's say next semester my team manages to get access to an enemy domain controller. what can we do? Well, one thing I devised was, I created a script that actually deploys a ton of group policy objects. So let me open up PowerShell ISE here. And then I'll just paste my script in here from GitHub. So the group policy objects that are actually deployed disable the firewall for all the boxes across the domain, enable SMB1 across the domain, store the LAN manager hash, enable print spooler, enable plain text passwords. So if I run Mimikatz and it gives me the hash, instead it'll actually just give me the plain text password, even for like Windows 10 systems. Disable LSA, so like random address memorization. It helps with like getting malware and stuff on the system and like letting it work easier. Enable wdigest, so if we want to, for Mimikatz, always install elevated, so we can actually, this is like, you install everything as an admin, like full permissions, so we can actually hijack that kind of stuff. We got zero logon, so this one, it just puts in a registry key required for the zero logon exploit to work. Weaken RDP, and this one's kind of optional, but it's to disable RDP. So like again, just prevent another team from scoring. So like what the weaken RDP does, it allows you to RDP anywhere without network level authentication. So like you don't have to be within a specific network range or anything. Just anyone from anywhere can RDP into it. And also allow more than one user to RDP at a time, so it doesn't like kick you off or ask for permission. So without further ado, let me paste in the script. So I won't get into too much detail about it. It just deploys a few data structures in here, so store stuff in an array, whatnot, get the domain, that's the domain name, and then once you put it in, deploy the group policy objects. And the way it does it, you set a name, then you set a registry value, because like when you click stuff like enabled, disabled, and like group policy management, it's all just corresponding to a registry key. You're just setting ones and zeros in the end. So it's just deploying the key. And then you just link it and enable it, and you're good to go. So let's run the script. As you can see, there we go. Oops, it didn't work because Active Directory was not running because I disabled the service. Let me, I'm actually going to revert to snapshot. So I'm going to pause the video real quick right here and just revert the VM to a snapshot. Okay, so I reverted to a snapshot. So now the script should run. So let's run it. It's going through, loading everything. Please enter in your domain name. Mine is just cartel.com. Press enter. Then bam, it's going to deploy everything. Some of them have issues, but because it's a corresponding key, but it still actually works. So just ignore the error message. Now, so great, all these group policy objects are deployed and their values are correct. So if I actually go to group policy management, you can see here, they're all here, and they're all made, and they're all linked. So, okay, so let's get started on persistence. So I'm just going to paste in my script from my GitHub here, PowerShell ISE. And yeah, so all we're doing here is creating thousands of users, placing them in various groups like domain admins or local administrators or remote management users, enabling the guest account. We're also making a user here, KRBTG, which is Kerberos. Well, not exactly. KRGBT is the real Kerberos user. So I just kind of switched the letters up and made a new user here. It'll kind of fool them into thinking like Kerberos, they can't delete it, the Kerberos user, because if you delete the Kerberos service account, like 80's broken. So a good team will know the difference between this and like the real Kerberos user, but for other teams, they'll be too scared to delete it, I think, and hopefully it'll let us stay in the system. So without further ado, let's run the script here. So as you can see, it's running, it's creating all those users. I think I had an issue before with one of the loops, but that's fine. It's still creating a couple of thousand of other users. So I'm going to speed this up because this is going to take a while. Okay, so it looks like it's done. So now if we go here,
just list all the users on the system. See, it's taken a while because there's so many now, but they were all successfully added. So this was a success. Now let's move on to the next form of persistence, which is deploying SSH. So I have a script that I wrote that automatically installs SSH on the system. So let me just go through the script here. So the way it works is it just downloads it from GitHub, actually. Someone posted OpenSSH for Windows 64-bit versions. It's going to put it in system32. It's going to unzip it using the compression function .io. It's going to install the scripts. It's going to generate an SSH key, and then it's going to start the SSH service. And then it's going to add a rule to open port 22 inbound so you can actually SSH into the system. And then it's going to hide the SSH folder. So you can't see it from like regular File Explorer. You'd probably be able to see it if you went in through command line, but a lot of people don't know how to use command line, unfortunately. So we'll fix that in case studies. Now let's run it. Okay, so I have resolved the DNS issue. So let me paste back in my code from GitHub. See, what we do is we just load in some assembly files here, well, like binaries for literally just so we can unzip a file. That's all the first two lines are. So then we download WinZip64 from GitHub, actually. We just put it in system32, then we extract it, and then yeah, we just run the install script. We generate an SSH key of RSA security type, 248 bytes. Then we just start the service. We add in a firewall rule to open up port 22, and then we hide the SSH file. So you can still see it, like if you run like the dir command in CMD or PowerShell, but it'll be hidden from like your folder. So anyway, let's start. So as you can see, it's loading everything. Great, SSH is up, starting, and it's generating our key pair here, generating the SSH key. Okay, so it looks like it finished. Now, let's try SSHing to the system. Let's open up Kali. And we put it wrong. Okay, welcome to the final part of the video. So my final script here, what it does, it automatically generates payloads here in Kali, and then once we get these payloads onto the target system, and once they're launched or executed, then it will spawn back reverse shells, and we can intercept those calls using either our native C2 server, Covenant, or just even Metasploit using the multi-handler to catch a callback connection. So yeah, just asks you to enter in your IP, passes it to the L host, and then that variable is just passed throughout these, so it knows where to get that callback connection to. So let's generate some payloads here. So let me just grab the IP real quick. 192.168.5.143. And you'll see the script runs. It'll start generating all of our payloads, and it'll keep everything here in this directory called Unicorn. So it looks like everything's generating right now. And while this generates, thank you for staying with me. I hope this video is not too long for you. I had a lot of fun, and I learned a lot building this project. And just thank you for giving me the opportunity to do it, and I hope this yields an A. If this takes too long, I might speed the video up. Oh, okay, it looks like it's done. Great. And the payloads are automatically generated. Thank you again.